Now let's use this molecular orbital diagram to identify the nucleophilic and electrophilic sites. Nucleophilic sites are the most energized electrons. The most energized electrons will be the highest energy electrons that we can find. Those are the most nucleophilic, the most reactive electrons, and they appear to be here. Similarly, electrophilic sites are those orbitals that are the lowest lying and that are empty. We call those lowest lying orbitals that are empty the LUMO, and so the pi star for carbon monoxide is the lowest unoccupied molecular orbital. In other words, pi star is the electrophilic sites. Now, if we look at those MO pictures, psi 6 and psi 7 correspond to the lowest unoccupied molecular orbitals, and we can again use the size of the lobe to indicate on which atom that LUMO is mostly centered on. And in each of these pictures, we see that the lobe on carbon is greater than the size of the lobe that's on oxygen. And so the LUMO, the most electrophilic molecular orbital, is predominantly located on the carbon atom. And so we would expect a nucleophile to attack the carbon based on the position of the LUMO. So we can use that same idea to go back and look at the nucleophilic site, which we call the HOMO for highest occupied molecular orbital. And in the case of carbon monoxide, it's that lone pair that we were talking about that's in the sigma sp star. Again, if we look at psi 5, which corresponds to that highest occupied molecular orbital, the greatest contribution was on carbon, and so we would say that carbon is the most nucleophilic site in this molecule. Psi 5 is the highest occupied molecular orbital, and it has its greatest contribution on carbon. So carbon is the most nucleophilic site. This behavior is borne out in the chemistry of carbon monoxide. Carbon monoxide can behave as a nucleophile, and when we look at it as a nucleophile, we would expect that lone pair on carbon to be the most nucleophilic site. Indeed, that's what happens when carbon monoxide binds heme. Carbon monoxide can also behave as an electrophile. When it behaves as an electrophile, a nucleophile would attack it. Which atom is it going to attack? Based on our LUMO analysis, we know that the attack of our nucleophile, in this case something like an alkoxide anion, attacks the carbon, the pi star, which has its predominant lobe on the carbon atom. That leads to this structure here, a new bond between oxygen and carbon.